My name is Christian M. Hermoso.
My name is Marnie Bicabudbon. I'm Joanna Marie A. Aguilion.
I'm Joshua Kim Enating,
And we are Team Pazar!
For today's topic is all about moment distribution method. Moment distribution method is the most suitable manual method for analysis of continuous beams and plane frames. This method was presented by Professor Hardy Cross of USA in 1929. This method consists in solving indirectly the equations of equilibrium as formulated in slope deflection method without solving the displacement. There are basic concepts on getting moment distribution methods. First is sign conviction. If it is counterclockwise moment or rotations, it has a negative value. Next, if it has a clockwise moment or rotations, it has a positive value. Next, on getting the distribution factor, it means the stiffness. The formula is K over summation of K. So, pagkuha na to sa stiffness, depende kung unsa iyang far end. So, kung far end niya is fixed, it means ang iyang formula sa iyang stiffness is 4EI over L. And if iyang far end is hinge or ruler support, it means ang iyang stiffness formula is 3EI over L. Kung ang iyang far end is continuous, so ang iyang stiffness formula is 4EI over L. Important note. So, kung ang imong distribution factor is kung ang iyang support is fixed, it means it has a zero distribution factor. And if kung ang iyang support is hinge, exterior hinge or ruler, it means it has a distribution factor of 1. There are processes of getting the moment distribution method. First is locking the joints against rotation. So, ang pasabot na ana is, if kung naakay isa ka beam, yan, naakay point diri, naakay fix here, A, then naakay ruler, B, and pin, C. So, kung naan niya siya load, uniform load, and this one has a consecutive load. So, ang imong pagbuhaton ana is imong ilang lock ang joint. So, from A to B, from here, imo na siyang ilock. So, ang mahitabo ana is maingana na siya, then ma-fix na po na siya sa gilid niya. So, it means, wala na siya malak na iyang rotation. And there are common fix and moments. So, this one, it is a restrained beam. So, it has a symmetrical load, which is in the center. So, ang iyang fix and moment sa AB, which is, ang iyang formula is negative PL over A. And ang iyang pong formula sa fix and moment sa BA is PL over A, positive PL over A. Next is, kung dili siya symmetrical. So, it's a restrained beam gihapon niya, naa siya both fix and sa end. So, ang iyang fix and moment sa AB is negative P B squared A over L squared. Ang iyang fix and moment sa BA is PA squared B over L squared. And ang iyang na uniform load sa isa ka restrained beams, ang iyang moment, iyang fix and moment is negative weight length squared over 12, and ang iyang fix and moment sa BA is weight length squared over 12. So, and the same way here na pagkuha gihapon sa fix and moment, which was derived in a theory. Next is distributing the balancing moment, and the last one is carry over moment. So, carry over moment is you need to divide into 2 or 50% of the distribution moment to the other end of each of the resisting moment. So, carry over moment will imbalance the joints of the structure. So, it means we need to repeat the process until ang value niya is approximately equal to 0 or negligible na siya into nga value. As usual, to further understand this concepts of moment distribution method is mag-provide two examples for beams and frames. We have an example here. So, compute the moment of each member. So, first is we need to compute the fixed end moment. So, mag-start ta dire sa A and B. Sa ako pang giingon ganina, we have two lock the joints para ma-lessen ang rotation. So, first is, kung mauna ta diri sa joint B. So, from here, so malak na siya. Then, naayatay load dira nga 80 kN and has the distance of 10, which is 5 meters and 5 meters. And natay ay nga 1.5 I. So, para makuha na to ang FAB, ako na ning napakita ganina ang iyang fixed end moment nga mga common nga mga formula. So, ang kani siya, which is, di ba, obvious nga symmetrical. So, ang atong gamiton nga formula para para makuha na to ang FEM sa BAB, which is kani, AB. Then, ang atong formula ana is PL over 8. So, which is ang atong natay load nga 80 and atong length is 10 then over 8. So, ang atong fixed end moment sa AB is equal to 100 kN meter. So, the same way sa pagkuha sa fixed end moment sa BA, nagyapon tayo formula ganina nga FEM BA is equal to negative PL over 8. So, which is same way nga na load nga 80. So, nalang na negative dira yan. Atong length nga 10 and we have 8. So, ang atong fixed end moment sa BA is equal to negative 100 kN meter. So, next is on getting the value of fixed end moment BC and CB. Para makuha na to ang fixed end moment sa BC is the same way na gyapon sa example ganina kay kuan man gyapon siya, symmetrical man gyapon siya. So ang atong kuan na is formula is FAM BC is equal to PL over 8, which has we have the load of 40 kN and the length of 10 and over 8, which is ang atong fixed end moment sa BC is equal to 50 kN M. The same way sa pagkuha sa atong fixed end moment sa CB, atong gapong gamiton nga formula is negative PL over 8, which is ang atong fixed end moment CB is equal to negative 50 kN meter. So, next is, we will get the distribution factor. So, take note, ganina, na kung fix ang iyang support, so, it means it has a zero distribution factor. So, it means, zero na siya. So, no need to kuan niya. Ang kani siya, ang iyang end man is ruler. So, ang iyang distribution factor is equal to 1. So, ang ato na lang din pangitaon is ang kaning B, joints B, nga iyang member is BA and BC. So, next is, di ba nga itong formula sa distribution factor is K over summation of K. So, we need to get the value of K and the summation of K. So, first is the K of BA. So, ang formula sa K is 4EI over L. So, we have the formula of KAB, which is ang atong I, natay I diri, nga 1.5 I over L nato nga 10. So, ang atong KAB is equal to 0.6. So, 0.6. So, atong butang rin, 0.6. Next is, we need to find the value of KBC. So, ang atong yapong formula na gamiton is 4EI over L. So, ang atong ato na nang ipang substitute ang mga value. So, 4E, which is I naman yapon, and 10. So, ang atong answer is 0.4. So, 0.4. Ang atong summation of K is, mauni siya, ato naman na siyang i-plus. So, we have 1. Summation of 1. So, and ang atong distribution factor sa atong BA, distribution factor nato sa BA is equal to, di ba, ang atong formula, ato na siyang ipang substitute atong value since nakakuha naman ta sa atong mga value sa example. So, next is 0.6 over the summation of K sa BA of BC, which is 1. So, ang answer ana is equal to 0.6 lang Japon. And next is the distribution factor of BC. C, which is ang atong K is equal to 0.4 nya. Ang atong summation of K is 1. So, ang atong yapong distribution factor of BC is equal to 0.4. So, since nakakuha naman ta sa atong distribution factor o ang atong fixed end moment, so we will just substitute the value here. So, from here, since naman tayo joints dire, dira, tayo A, then A. So, di ba nga remember nga, atong distribution factor sa A is equal to 0 since ang iyang support is fixed. So, butang ta dirag 0. Ang kani siya, nakakuha ta dirag distribution factor ganina nga 0.6 o ang distribution factor sa BC is 0.4. And ang atong distribution factor sa C is 1 since ang atong support dira ay is ruler support. So, next is, ang i-add na to ang atong nakuha nga fixed end moment ganina. Atong nakuha nga fixed end moment sa AB is 100. Ang atong nakuha nga fixed end moment sa BA is negative 100. And ang atong nakuha nga fixed end moment sa BC is 50. The same way, ang atong nakuha nga fixed end moment sa CB is negative 50. First is, ang atong buhaton is first distributing method. So, atong buhaton dire is we will just multiply. So, 100 times 0, so it means 0. So, next is, since naaman siya sa isa ka join, so ato ning i-add, then it multiply sa kaninga portion. So, negative 100 plus 50 nya ato na i-multiply sa times 6.6. So, multiply by 0.6. Ang atong answer, ana, is equal to negative 30. So, since negative 30 man yung value diri so positive 30 ni diri. The same way sa atong value diri ato na gyapon ni i-add, then multiply by 0.4, which is equate to 20. Since negative, ayan naman siya. So, negative 100 plus 50 multiply by 0.4. Ang atong nakuha ni is equal to negative 20. Since negative na yung value, so ibutan na to diriha is positive 20. So, ang diriha, the same, atong i-multiply, negative 50 times 1. So, since negative 50 man answer, so atong ibutan diriha is positive 50. So, this is our first factor or first distributing factor. So, next is the carryover moment. So, ang carryover moment is you just need to divide or cross over nga divide. So, from here, kani, imo nang i-divide into 2. So, since 0 man, so 0 ni siya. So, from 30, imo na siyang i-cross over dira, i-divide og 2, which means, answer is 15. Yan. Diri po, same way diri, ato na i-divide into 0, cross over, so, which is 10. Yeah, the same way here. So, 25. Since, dili pa man negligible ang value, so, we need to repeat the process hangtod sa negligible na gyud ang value, na, which is approximately to 0. Again, we need to repeat the process. So, 15 times 0 is equal to 0. Then, since ang kanisya both is naman sa isa ka join, so we need to add, then multiply by 0.6 from here, then ang isa po is 0.4. So, ang atong nakuha diri is 0 plus 25 times 0.6, which is equate to 15. So, ang atong answer, since positive man diri, so negative ang atong diri 15. So, next, diri ang portion sa right side sa joint B, so 0 plus 25 times 0.4, ang atong answer na is 10. So, since positive man diri, so negative 10 diri. So, same diri, so 10 times 1, so carry over ng 10, since positive man, so negative 10 na siya diri. Next is, di ba humana, so nanapunta sa another kuan. So, mag-crossover moment na punta. So, same way diri, i-divide gyapon nato ng 2, so 0 gyapon na siya. Then, ang kaniya po diri is i-divide gyapon nato na siya 2, so 7.5, negative 7.5. Yeah, diri divide gyapon nato siya 2, so negative 5. Then, ang diri i-divide po nato siya 2, so negative 5 lang gyapon. So, repeat the process antod nga mahuman siya. So, after repeating the process, so naka-came up og value nga 0, 0.003, 0.002, and 0.5. So, I need to stop there because ang iyang value is almost approximately to 0. So, para makuha na to ang moment of AB, moment of BA, moment of BC, and CB, so, you just need to add this column, this column, this column, and this one. So, at pag maano to niya, atong answer ana is 108.35. So, which is positive man siya, so it means clockwise. This one, kung imo na siyang i-add, maka-came up tag value nga negative 83.325. Since negative man siya, it means it's counterclockwise. Diri naka-came up og value nga 83.325, which is since positive man siya, so clockwise. And diri naka-came up og 0. For our next example, so we have here frames. So, atong pangitaon diri is ang reactions and moments for each joints. So, first na to buhaton is to lock the joints. So, each joint. So, diri ta mag-start sa AB. So, sa ato siyang gawin 20K and with 2 meters and 2 meters. So, this one, A and B. So, first na to buhaton is kwaon ang fixed end moment sa AB. Ang fixed end moment sa AB, which is here. So, ang atong formula gamiton is PL over 8, which is to negative. So, FEM AB is equal to negative. Atong load here is 20. Then, ang atong length is 4 over 8. So, ang atong answer, naka-came up tag-answer na negative 10 kN. The same way sa pagkuha sa FEM BA. So, same formula. So, naka-came up tag positive 10 PNM. Next joint here is ang B ug ang C. So, ato i-drawing para visualize gid nato. So, ana. So, B and C, which has a load of 15 kN of there. So, para makuha nato ang fixed moment sa BC o fixed moment sa CB, so we need to use the formula of fixed moment of BC nga katong ay weight times length squared over 12. So ato rin nang i-substitute ang mga value, which is natay weight na 15 times ang atong length na to nga 5 square nya over 12. So naka-came up ta og 31.25 kN times M. It's negative. So, next is, para makuha na to ang fixed moment sa CB, so, same gapon nga formula itong gamiton, which is katong positive. So, FEM CB is equal to positive 31.25 kN M. So, next is kani nga members sa joint C. Next is kwaon nato ang fixed moment sa DC ug ang sa CD. So, fixed moment sa DC ug fixed moment sa CD. So, ang atong gamiton nga formula since symmetrical naman siya, so same ra siya sa kani nga kuan member. So, pagkuha CD is equal to negative load of length over 8. So, we just need to substitute the value. So, natay ko ang nga 20, length na 4, and then 8. So, we came up with negative 10 kN. The same way sa pagkuha sa fixed moment sa DC, which is same formula as this, pero positive lang. So, naka-came up that 10 kN. Next is we need to get the distribution factor of each joint. So, from here, sa sa kaninga joint, sa B, naa siya member nga BA o BC. So, ato ibutan dali, BA and BC. Sa joint C, na po siya member nga CB o CD. So, ato ibutan dali, CD o CB. So, Next is, kwaon nato ang K. So, katong K nga formula, which is 4EI over L, if katong fixed end, which is, ako na siyang i-discuss ganina. So, atong gamiton diri ang formula is 4EI, which is ang I diri nga portion is 2I, which is given, over 4. So, ang atong answer is 2EI. Next is, the same, since ang iyang, sa BC, since continuous man siya, ang atong gamiton nga formula sa stiffness, which is ang katong K, is 4EI over length gihapon. So, ang length ani is 5. So, ang atong answer is 4EI over 5. Next is, paano na to ang K sa CD, ang stiffness sa CD. So, kani, CD o CB. So, ang CD, same na siya nga, ang iyang kwan is fixed end. So, motong atong formula is 4EI over length. So, 4EI over 4. So, which is, naman siya 2I nga given. So, which is, nakakame up ta og 2EI lang gihapon. Sa 4CD na siya. For the stiffness of CB, since continuous man siya, so ang atong formula is this one. So ang length niya is 5. So na-came up ta og 4EI over 5. So atong buhaton diri is we just need to add this one. So BA ug BC. So i-add nato ang 2EI plus 4EI over 5. To simplify this one, so ang atong ma-came up ana is 14EI over 5. The same way here, sa CD, member CD ug CB, imura na siyang i-add. So, 2EI plus 4EI over 5. So, naka-came up gihapon ta, since the same naman sila, so 14EI over 5. So, para makuha nato ang distribution factor sa BA, distribution factor sa BA, so imura to siya kani nga formula, which is K over summation of K. So atong K diri sa BA is 2EI over ang iyang summation is kani 14EI over 5. So naka-came up ta diri og 5 over 7. Next is para makuha na to ang distribution factor sa BC. So, same way nagapon ang gamito na to diri DF of BC. So, nakuha ang atong K diri is 4EI over 5. Tas ang atong summation of K is kuan. Ato na lang na siyang i-reciprocate. So, 5 over 14EI, which is naka-came up ta og 2 over 7. So, next is para makuha na to ang distribution factor sa CD. So, same way na gihapon. So, naka-came up ta sa CD at naka-came up ta og 5 over 7 og ang atong distribution factor sa CB is 2 over 7. So, since naalaman tayo mga value sa atong fixed end moment and distribution moment, so dito na ta sa table. Since nakakuha naman tag value sa different distribution factor and fixed end moment, so ato lang na siyang i-substitute diri kaya para makahimo ta atong table sa carry over moment. So here is 0, atong BA is 5 over 7, atong BC is 2 over 7, atong CB is 2 over 7, atong CP is 5 over 7, and atong DC is 0. Ato pong fixed end moment ganina, ang AB is negative 10, ang BA is 10, ang BC is negative 31.25, ang CB is 31.25, ang CD is 10, and ang atong lastly, ang atong DC is 10. So, our first distribution factor, so, ano na siya? First is katong i-multiply mo. So, negative 10 times 0, so 0. So, next is, since naman sa isa ka joint sa B, so, katong pareha na itong ganina sa beam nga, i-plus na to niya, then multiply this from sa iyang DF. So, ang mahitabuan na is 10 plus negative 31.25, kana siya, times the 5/7. Ano na siya? Over 5/7. So, ang answer, ana, is equal to negative 15.179. Since negative man siya, so, positive ang atong value diri. So, butang na to, 15.179. The same way sa process diri. So, 10 plus negative 31.25, then multiply sa 2.7, sa 2/7. So, ang naka-came up ta o negative 6.071. So, since negative man siya, so atong value diriya is positive 6.071. So, same ra gyapon since naman siya gyapon sa isa ka join sa CB ug CD. So, i-add gyapon na nimo. So, imo gyapon na siyang i-add, which is 31.25 plus 10 times 2/7. So, naka-came up ka o positive 6.071. So, since positive man atong value diriha, so negative 6.071. The same way na gyapon ang process niya. So, 31.25 plus 10 times 5/7. So, naka-came up ka value nga 15.179. Since positive man ang 15.179, so ang atong value diri is negative 15.179. So, kani 10 times 0, so as is na 0. Next is diri ta sa pag crossover moment. So, i-crossover moment, so kato ganina nga i-divide mo siya og 2, the same way diri i-divide mo siya og 2. So, 0 divide 2, so as is na 0, then 15.179 divide 2 is 7.59. Then, this one, imugya pa na yung crossover moment. So, 6.071 divide 2 is equal to 3.036. Same here nga, i-divide gahapon nga 3.036, but this time it's negative because negative 6.071 divide 2 is negative 3.036. So, the same way here, yung magyapan na crossover moment, i-divide into 2. So, 0 divide 0, 2 is 0. Then, ang negative 15.179 is negative 7.59. So, the same way gapon, i-repeat rin mo ang process hantod maka-came up approximate nga equal to 0. So, after getting the value of 0.003, 0.006, and so on, is we need to add to get the final moment of each member. So, the moment of AB is equal to negative 1.14. Imura ni siyang add nga column, this column to column. I-addan mo siya. Muna na siya yung moment sa each member. So, ang moment sa BA is 27.71. Ang moment sa BC, which is imo rin yung i-add, is negative 27.71. Ang moment sa CB is 27.71. Ang moment sa CD is negative 27.71. O ang moment sa DC is 1.14. So, nakuha na nato ang moment sa each joint. So, after getting all the values of moments in each joint, so, muna ni siya ang 1.114, 27.71. Take note nga, each negative nga atong nakuha ganina, counterclockwise to siya, o gatong mga positive nga mga value, clockwise to siya. So, next is kwaon nato ang mga reactions ani nga member. So, dili ta mag-start sa A o B. So, AB, B. So, naatay horizontal load diri naputay horizontal nga load diri So, naatay 20 kN. Here nga, naatay moment ganina nga nakuha na nato nga 27.71 o moment diri nga sa AB nga 1.14. So, we just have to get the moment at B. So, moment at B is equal to 0 at clockwise positive. So, for HA, ang iyang kuan, this one also is counterclockwise, so positive 27.71. This one is negative since it's counterclockwise, negative 1.14. Nga ang atong load na 20 padulong sa B, which is negative since counterclockwise nun siya. So, negative 20 times 2. So, is equal to 0. So, ang atong HA here, ang atong reactions at A is equal to 3.36 kL. So, next we will get the reactions of B sa horizontal reactions at B. So, we just need to get the horizontal value. So, it's kaning formula. So, 20 kN is equal to HB plus the value of HA nga, which nakuha na nato ganina. So, 3.36 kN. So, ang atong value sa horizontal B is 16.64 kN. So, next is we need to get the reactions of BC. So, since na naman tayo mga moment ganina, ato ra na siyang isubstitute diri R. So, makuha na to ang moment at B is equal to 0, positive moment. So, since mama na itong B, mao ni atong C, atong resultant here nga 15 times 5 times katunga sa 5, so 2.5 minus 5 RC minus kani positive negative 27.71 plus kani 27.71 is equal to 0, which is mag-0 raman na siya. So, ang atong RC here is 37.5 kN. Sa pagkuha na to sa nanatay RC. So, sa pagkuha na to sa RB, so, magkuha na tag horizontal reactions, which is gamiton natin yung kuan summation of forces along y-axis. So kani nga nanatay value sa RC nga 37.5 plus RB na unknown, then ang iyang pakuan nga 15 times 5. So ang atong RB is equal to 37.5 kN. For the last number, CD, so ato na siyang ikuan C o D. So, natay horizontal reaction nga HC o horizontal reaction sa HD. Then, naatay as is nga load nga 20 kN. And naaputay moment ganina nga kuha nga 27.71 o diri 1.14. So, the same way nga mag-moment ta para makuha na to ang mga value sa HC o HD. Rather, this one is HD. So, M at D, 0, positive, clockwise. So, 4HC minus 20 times 2 plus positive 1.14 plus negative since counterclockwise 27.71 is equal to 0. So, ang atong value sa HC is equal to 16.64. Which is the same way sa magkuha ta summations of horizontal reaction sa para makuha nato ang HD. So, HD plus the value of HC nga 16.64 is equal to 20 kN. So, the value of HD is 3.36 kN. Thank you.
So the next topic that we'll be tackling is the three-moment equation. So the three-moment equation, it gives us the relation between the moments between any 3 points in a beam and the relative vertical distances or deviation. This method is widely used in finding the reactions in a continuous beam. So the main purpose of the three-moment equation is to solve the beam reactions, and it can also be used to solve the beam deflection. So after that, we can use the general equation of the three-moment equation, which is ML times LL over EL times IL plus 2 times MC times LL over EL times IL plus LR over ER times IR plus MR times LR over ER times ER plus the 3-moment equation, which is the 6A bar A over EL times IL times LL plus 6A bar B over ER times IR times LR equals to -6 times the left settlement minus the center settlement over the length of the left plus the right settlement minus the center settlement over the right settlement. ML times LL over the flexural rigidity of the left can be seen in here. While the 2MC, which is the moment of the center, is in here. Just like parehas lang dere, ang length of the left can be seen here. While MR times LR can be seen here. While the length of the right is here. And the flexural rigidity of the right is here. So as we go back to the general equation of the 3-moment equation, if E is constant, we must eliminate E value in the general equation. You can use 1 over E in order to eliminate the E. So if E is constant, E will be eliminated in the general equation of the 3-moment equation, which will be something like this. ML times LL over IL plus 2MC times LL over IL plus LR over IR plus MR times LR over IR plus the 3-moment equation, which is the 6A bar A over IL plus 6A bar B over IR equals to 0. So nga nang mahimo man siyang 0, na 0 siya, na-eliminate ng -6 times the left settlement minus the center settlement over the length of the left plus the right settlement minus the center settlement over the length of the right. Because wala siya, kuan lang siya, applicable lang siya if naa kay supported load. Unya kay wala man, so ma-eliminate siya. So, may equals na siya to 0. Muna na naman siyang 0 direct. So, what about kung ang EI or the flexural rigidity is constant? So, basically, ang maligwak na nimo diri sa general equation is the IE. So, ang imong ibutang diri 1 over EI in order to eliminate the EI in the equation. So, if EI is constant, i-eliminate nimo ang EI diri sa general equation. So, mo ni ang mulugwa. ML times LL plus 2 times MC times LL plus LR plus MR times LR plus the 3-moment equation, which is the 6A bar A over LL plus the 6A bar B over LR equals to 0. So, asa day ni nakuha ning 3-moment equation since na-explain naman ni Mujo ang moment of the left, moment of the center, ug moment of the right, length of the left, and length of the right. So, we have factors that we consider para sa atong 3-moment equation, which is akong ipakita karon. So, these are some examples of factors for the 3-moment equation. So, type of loading, which is the concentrated load anywhere on the span. for 6A bar A over L, the equation would be PA over L times L squared minus A squared. While for the 6A bar A over L, the equation will be PB over L times L squared minus B squared. So for the uniform load, in the left settlement will be W times L cube over 4, while in the right settlement will be load times L cube over 4. For the increasing triangular load over the entire span, for the left settlement will be A times weight times L cube over 60. For the right settlement will be 7 times weight times L cube over 60. For the increasing triangular load over the entire span, for the left settlement will be A times weight times L cube over 60. For the right settlement will be 7 times weight times L cube over 60. For the decreasing triangular load over the entire span, so gibali lang to siya, no? Same lang yapon sila og formula, but gibali man ang triangle. So ang 7 times weight times L cube over 60 is na siya sa left nga settlement. So in the right settlement, dito rin butang ang A times weight times L cube over 60. For the concentrated load at the span, so in the left settlement, we have 3 times PL squared over 8. So same lang sila og ano kanang equation from the left settlement to the center and the right settlement to the center. So moment load at any point, we have in the left settlement negative M over L times 3A squared minus L squared. In the right settlement, we have positive M over L times 3B squared minus L squared. For the isosceles triangle load over the entire span, we have 5 times weight times L cube over 32 in the left span, while in the right span, we also have 5 times the weight times the length cube over 32. Same lang ang left settlement and the right settlement equation. So in the general uniform load, we have weight over 4L times B squared times 2L squared minus B squared minus A squared times 2 times L squared minus A squared. So in the right settlement, we have weight over 4L times D squared times 2L squared times D squared minus C squared times 2L squared minus C squared. So to understand this further, the factors of the 3-moment equation, let us have an example. So this is our first example, and we have a continuous beam with a uniform load from the center to the right settlement. So naatay upat ka reaction since naman tay isa ka hinge og duha ka ruler. Og naabot tay load na 150 kN og 100 kN. And E is constant. So from the general equation of the 3-moment equation, which is ML times LL over EL times IL plus 2 times MC times LL over EL times IL plus LR over ER times IR plus MR times LR over ER times IR plus the 3-moment equation, which is the 6A bar A over EL times IL times LL plus 6A bar B over ER times IR times LR equals to 0. equals to 0 since wala man siya supported beam. Since ang E kay constant man, so atong i-eliminate ang E diri sa atong general equation. So, mo nang nahimo ni nga ML times LL over IL plus 2MC times LL over IL plus LR over IR plus MR times LR times IR plus the
column shear.
3-moment equation from the left and the 3-moment equation from the right over 0. So, first thing to do is mag-indicate ka kung asa imong center, imong right, o ang imong left. So, mag-center na diri. Kunwari, this is A, this is B, and this is C. So, dito sa B mag-center, yatong left is atong A, yatong right is ang C. Pagkahumanin mo, indicate sa imong left, center, of right, imong i-substitute ang mga values diri sa imong modified nga equation. So, mo ni ang mulugwa, since ang imong ML or the moment of left, kay naman siya sa A, so mo ning moment of A times iyang length na 6 over the, since ang I kay kuan man na may value, so imo lang i-substitute ang 2i plus 2 niya imong center is from naman siya sa B, so mo nang nahimo siya og moment from B times 6 na length from the left over the 2i plus length nimo from the left settlement over I times MC kay ang imong right settlement kay naman siya na locate sa C times length niya na 5 kay gikan man siya sa right nga settlement over the I which is kani plus so mo to akong giingon gaina nga ang kaning the 3-moment equation which is the 6A bar A over IL times the length of the left mo ni siya. Since kay ang imong type of load man kay concentrated load, so mo ni ang imong gigamit na formula which is the PA over L times the L squared minus A squared. So imo rang i-substitute ang mga values dire sa imong equation nga PA over L times L squared minus A squared mo ning nilugwa since ang imong 150 kaya namon siya area nga 2 over the overlength sa imong left na settlement which is the 6 times the length overall nga length squared minus the area which is the 2 para sa po siya sa 100 since naman kay load diri nga 100 so imo nang i-substitute yang iyang area nga 4 since gikan sa A nimo hantod sa load nga 100 na kay 4 nga distance so imong ibutang over the length of the left which is the 6 kapira nimo ang 6 squared minus ang katong distance niya from A to 100 nga load mo nang nakakam up ka sa 2,933.33. So, ang next na ito nga pangitaon kay ang 3-moment equation from the right settlement. So, ang atong right settlement man is uniform load. So, kani ang atong gamiton na formula. Which is, naman siya sa right. So, weight times the length cube over 4. So, imo ra gyapon i-substitute which is the 50 kilonewton per meter cube over 4. So, mo nang nag-come out ka o 1,562.5. Equals to 0. Since ang imong I man is constant, so ato nang i-eliminate. So, pag gumanog eliminate sa imong I, nikamap ka aning 6MA plus 2MB times 3 plus B time plus 5MC plus 2,933.33 over 2 plus 1,562.5 over 0. So, imo siyang i-factor out ang kuan 5MC o ang 3MA. Since pag natunong ang imong moment sa hinge o sa roller nga nasa end, kailangan mo siya eliminate since wala man na siya kuan moment. To get the MB, i-shift solve lang nimo kaning 16 MB plus 3029.152 equals to 0. So mo nang i-come up ka og negative 189.322 kilonewton per meter. Muna ang atong equation 1. Since na naman tayo MB, so if we compute all the reaction, so magsugod ta at AB, so summation of moment at B equals to 0. So negative RA times 6 plus 150 times 4 plus 100 times 2 times MB equals to 0. So muna ni come up ta sa RA nga 101.77 kilonewton per meter. So, forces through vertical, ang RA plus RBL equals to 150 plus 100. Since naman tayo value sa RA, so substitute lang nato na mo nang i-come up ta og 101.779 plus RBL equals to 150 plus 100. So, muna nilugwa ang answer nga RBL is equals to 148.221 kilonewton. So, kay nakuha naman nato ang at AC, so dili na punta sa at BC. So, submission of moment at B equals to 0. RC times 5 minus 50 times 5 times 2.5 plus MB equals to 0. So, since ang nanamang kay value sa imong MB which is 189.323, so imo ra siyang i-substitute, mo nang nakakuha ka og value nga 87.1354 kilonewton. So, forces vertical, so naamang kay RBR plus RC equals to 50 times 5. Since na naman kay value sa imong RC, imo lang yapon i-substitute, mao nang naka-come up ka og answer nga 162.8646 kilonewton. So in order para makuha nimo ang imong value nga reaction from B, imong i-sum ang imong RBR o RBL. So i-sum up man nato ang para makuha nato ang RB, i-sum up nato ang RBL plus RBR. So, munang natay 148.221 plus 162.8646. Munang nakakam up ta og answer sa RB or the reaction B nga 311.0851 kilonewton. So, let's proceed sa atong second example. So, naatay continuous beam diri nga naay increasing triangular load nga naay load nga 150 kilonewton per meter og naapod ta uniform load which is 50 kilonewton per meter. Nya naapod tay load diri sa B which is 400 kilonewton og center sa BC which is 300 kilonewton. Since ang atong EI is constant, same lang gyapon sa atong general equation, sa atong 3-moment equation nga atong eliminate ang atong EI. So, munang may come up ta ani nga equation which is ML times LL plus 2MC times LL plus LR plus MR times LR plus the 3-moment equation which is the 6A bar A over LL plus 6A bar B over LR equals to 0. So, ang atong next nga buhaton is mag-indicate ta asa ang atong left og center og ang atong right. So, kuano na to nga diri ang atong center sa B og ang atong left is diri sa A og ang atong right is diri sa C. So, the next thing nga atong buhaton is ato lang i-substitute ang atong value diri sa atong equation. So, ato may substitute ang atong value diri sa atong equation. So, mo nang ni-come up ta og MA times 12 plus 2MB times 12 plus 12 plus MC times 12. Nanong MA, like, para sa akong example gaya na sa number 1, sa akong explanation dito sa number 1, nga, since ang atong left, na itong gibutang nasa A, mo nang nahimo ni siya og moment from A. Ang kaning MC, since ang atong center kay atong magibutang sa B, so mo nang nahimo siya og moment from B. O ang atong MR is naman siya C, so may mo siyang moment from C. Teraz gayon nga explanation, dito magkuha gyapon ta og formula nato sa atong 3-moment equation sa katong factor of 3-moment equation. So in order to get the 3-moment equation from the left settlement, maong nakakam up ta ani nga formula para sa po datong akong i-explain sa example number 1 nga gikan siya diri sa factors of 3-moment equation. Munang nakakam up ta aning 8 times y times L cube over 60. Munang ang atong 3-moment equation from the left settlement is 34560 kilonewton per meter squared. While ang atong 3-moment equation from the right settlement, same lang gyap man diri nga nagkuha ta og formula, since ang ato man dira is concentrated load, mo na atong gikuha na equation. Mo nang nakakam up ta og 31,700 kilonewton per meter squared. So, since ang atong moment from A kay naaman siya sa end nga part and naa siya hinge nga support, so equals ni siya og 0. So ang mabili na lang is 48 MB plus 12 MC equals to negative 66,260. Muna ang atong equation 1. Since ang atong equation 1 kay na may duha ka unknown, so kailangan na to mangita og another na pod nga center in order to cancel og makuha ang mga reactions. Ibutang na to atong center sa C, ug ang atong left sa B, ug ang atong right diri sa middle sa CD. So, mo nang nakam up ta nga ang atong ML is MB, atong MC is MC, nya atong MR is equals to MD. So, mura gyapon nang atong gamito na formula no kay since EI is constant man, so i-repeat ra na to atong process no, gi-substitute na to ang mga value diri sa atong equation. So mo nang nakakam up ta og MB times 12 plus 2MC times 12 plus 12 plus MD times 12 plus 29,500 plus 21,600 equals to 0. So, I think kabalo naman siguro mo giunsa pag-solve ning 3-moment equation from left settlement o right settlement, no? So, mo nang nakakam up ta ani nga answer, which is 12 MB plus 48 MC plus 12 MD equals to negative 51,100. So, since ang atong load diri is uniform load unya continuous beam siya, so pwede na to ma-solve ang atong MD. So, atong ikat ang kuha na to, load diri, which is ni come up ta ani nga figure, which is kung kuha na to ang moment from D, kailangan na to mag-moment sa D. So, muna i-come up ta og negative 50 times 4 nga distance niya katunga niya plus ang moment nga MD equals to 0. Mao nang nakakam up ta og answer nga MD is equals to 400 kilonewton per meter. Since naa naman tayo kuan value sa atong MD, ato na lang i-substitute diri nga equation in order for us to get the MB o MC para ato na lang ma-eliminate siya sa equation 1 o equation 2. So ato nang na-substitute ang atong answer nga MD diri nga equation, no? Muna na-come up taani nga equation which is 12 MB plus 48 MC plus 12 times 400 equals to negative 51,100. Mo nang ang na-come up ta og equation 2 which is 12 MB plus 48 MC equals to negative 46,300. So the next step is mag-elimination method na tas sa equation 1 o equation 2. So, in order for us to get the moment A, moment B, moment C, and moment D, kailangan nato mag-elimination method sa atong equation 1 and equation 2. Mo ni atong equation 1 which is 48 MB plus 12 MC equals to negative 66,260. O ang atong equation 2 is 12 MB plus 48 MC equals to negative 46,300. So, kaya bala naman siguro ta, para mas dali ang atong magkuha na to ang answer, maggamit na lang tao sa atong cycle which is mode 5 niya, number 1. So, mo nang nakakam up taog, MA na to equals to 0 since kay naaman siya diri na tunong sa may hinge nga support, mo nang 0. Unya, ang MB na to is equals to negative 1,215.222 kilonewton per meter. Unya, ang atong MC is equals to negative 660,778 kilonewton per meter. Nya, lastly, ang atong MD is equals to negative 400 kilonewton per meter.
Our next topic is all about portal method. Portal method is one of the common approximate method in the analysis of statically indeterminate structures. This method is used to analyze the frames which subjected to lateral loadings such as wind, earthquake, and blast loadings. We have here a assumptions. Number 1, point of inflection at the center of each girder. So if natay beam, nasa tunga ang inflection. Number 2, point of inflection at the center of each column. So kung natay pusti diri, nagyapon sa tunga ang inflection. Number 3, the total horizontal shear on each story is divided between the column of the story so that each interior column carries twice as much shear as each exterior column. So kung pila ang pasabot anis, kung natay column diri kung pila ang imong exterior is kaduhaon da nimo ang imong interior column. So kung ang atong exterior is single shear, so ang atong interior shear nato is double shear. So para mas masabtan ang portal method, we have here example. So ang gipangitaan ni diri is determine the shear of point G, H, and I. So first nato nga buhaton is ato sang i-determine ang number of shear. So natay duha ka single shear plus isa ka double shear. So we have here 4 shear. Equal sa na siya nimo kung pila ang load nga nakabutang diri sa atong example. So we have here 800 kilonewton. So ato na siyang i-divide by 4 both sides. So cancel. So 800 divided by 4 is 200 kilonewton. So mao na ni siya ang atong single shear. So single shear man ang G. So ang G is 200. Ang I pod is 200 pod siya. So ang nakabutang sa assumption nato is ang interior, which is the edge, is double man siya sa exterior. So we have to multiply 200 kilonewton by 2 para makuha nato ang H. So we have 400 kilonewton. And now let's proceed to example number 2, which is determine the moment at point B, C, and D. So before we are going to makam up na to ang moment at point B, C, and D, ato sa pangitaon first ang atong. So as I said earlier nga ang atong shear sa outer is single shear, and then atong shear sa inner is double shear. So V2. Here is V1. So how can we get the shear? So ato ra gyapon na siyang i-determine ang numbers of shear sa atong column. So 2 plus 1 plus 1 is equals to 4 shear. And then equals lang gihapon nato sa atong load nga 50 kilonewton. Next is divide by 4 both sides. Cancel. And ang mabilin is 50 kilonewton over 4, which is equals to 10 kilonewton. After nato makuha ang shear, sa ato na dayon siyang i-butang diri a. O atong shear. So single shear naman siya, 10 gihapon, 10 kilonewton ra gihapon ang atong ibutang. So ang atong inner column is double shear man siya, so ato rang i-multiply by 2 ang atong nakam up nga answer sa single shear. So 10 is equals
times 2
to 20 kilonewton. So single shear mo lang gihapon 10 kilonewton. And now, naanaman tayo shear both column, and makuha na nato ang moment kada column. So, unsaon pagkuha sa column moment. So, sayon na siya guys. So, kung pila ang total distance ani diri is nakakuha naman tag shear diri naanaman tayo shear sa center. So, ato na siyang tungaon ang total distance. So, naatay 2.5 meter nga distance. So, unsa ang pagkuha ang moment? Just multiply the shear times sa nakam up nato nga 2.5 meter. So, diri sa single shear na isa is we have 10 kilonewton times 2.5. 10 kilonewton times 2.5. We have moment here is 25 kilonewton. So kani diri sa ubos sa A is same raman silag distance, pareha raman silag tuyok, same lang gihapon sila og value 25 kilonewton. So diri sa double shear is maura gihapon ang atong himuon. I-times ra gihapon nato ang shear diri sa 2.5 nga distance. So 2.5 times 20 equals, we have here a moment, we have here 50 kilonewton. So, pareha lang gihapon silang distance, same ra gihapon silang tuyok, 50 kilonewton gihapon. And diri sa point F and A, same raman sila diri sa B and A and B, same raman silang distance, same raman sila og single shear. So, mao lang gihapon 25 moment, 25 kN. 25 kN. So nakuha nato both sides or kada column nakuha nato ang tanan moment. So unsa gipangita sa atong example, determine the moment at point B, C, and D lang. So na naman tayo mga value tanan. So ang ato lang ang gipangita raman niya is B, C, and D. So ang moment B at moment B is equals to 25 kilonewton. Ang atong moment C at point C is, we have here the double shear. Moment C is equals to 50 kN. Ang last nga gipangita is moment D, which is naa diri ang nakuha nato is 25 kilonewton. And that's all. Thank you.
Cantilever method. Cantilever method for analyzing fixed supported building frames requires the following. A hinge is placed all the center of each girder, since this is to be a point of zero moment. A hinge is placed at the center of each column, since this is assumed to be a point of zero moment. The axial stress in a column is proportional to its distance from the centroid of the cross-sectional areas. Then, in the special case of the column having equal cross-sectional areas, the force in a column is also proportional to its distance from the centroid of the areas.
Problem number 1 for cantilever method. Analyze the frame using cantilever method. All the members have the same cross-sectional area.
The points of contraflexure or points of inflection of the moment diagram in both the vertical and horizontal members are located at the midpoint of each member. The axial stresses in the columns are proportional to their distances from the centroidal axis of the frame.
In this frame, in the top and bottom stories, let us name the center of the columns. So, tungaon na to ang frames kaduha, which is the top and the bottom. So now, let us find the location of center of the gravity. We all know that all of the members are having the same cross-sectional area. Let us keep the area A for the member IQ. The horizontal distance is 0 when we multiply area A. So we have calculated the X bar from the member IQ, which is here from here. So the distance between the center of the gravity and IQ is 8 meters. So from nakuha nato daw ang kanang ang iyahang ang center is from member I to here. So mao na diri nato ang atong center of the gravity. So ang total distance ana niya is 8 meters. The distance between the member GR and the center of the gravity is 8 minus 4, so we got 4 meters. So ang diri ako daw niya gikan sa member G and R, ang total distance niya ra nakuan is 4 meters sa siya. 4 meters. And then the distance between the center gravity of KS, diri na po daw, is 10 minus 8. 10, total aning distance diri, minus 8, so you get 2. Correct. Ana, 2. Dira, 2 meters. And then, the distance between LT is 18 minus 8, so we get 10 meters. From diri daw to total diri is 10 meters. Now, let us name the vertical force in the point Q as VQ, R as VR, and S as VS. At the midpoint, T as VT. Side of center of the gravity forces will tensile and the right side will be compressive. So ako pang giingon kagaina para dili maglibog ang tanan. Ang giingon ako gaina nga atong frame is tungaon nato kaduha. Ang top o ang bottom. So para di maglibog kagaina, ang akong gibuhat kagaina, dili na ako mapakita diri sa video kay na-consume na the stress. We need to know first the formula on how to get the stress. So mao ni ang ato ang formula of stress. Stress is equals to force over area. So akong gisulti kagaina,
ang atong V is i-denote nato siya as a VQ, ang R is VR, ang S is VS, and so on and so forth. And then, sa gikuha na to kagaina is the stress Q over A over 8 is equals to VR over A over 4 is equals to VS over A over 2 is equals to VT over A over 10. And then, i-cancel na to ang A kay para ang mabilin is VQ over 8 is equals to VR over 4 is equals to VS over 2, and then VT is over 10. And then to get the value of the VQ is we need to expression for VR, VS, and VT should be in terms of VQ. So to get the VR but in terms of VQ, imo ni siyang i-divide. And then VR is equals to VQ over 8 times 4. So you get 0.5 VQ. Kay in terms man nato siya sa VQ. And then parihara po siya sa atong buhaton sa VS, which is VQ is over 2 times 2 is equals to 0.25 VQ. Then same reghapon sa VT, VQ over 8 times 10 is equals to 1.25 VQ. So now, to get the value of VR, VS, and VT, you need to multiply by 5 sa itong nakuha kagaina nga VQ, which is 5 kilonewton. So ang VR is i-multiply lang nato siya og 5. So which is 0.5 times 5 is equals to 2.5 kilonewton. Then VS is 0.25 times 5 is equals to 1.25 kilonewton, and then the VT is 1.25 times 5 is equals to 6.25 kilonewton. And we have calculated the actual forces just above the center of the columns. So mao ni ang atong mga values sa Q, R, S, and T. Moto sila ang mga axial forces. So now, let us split the frame into two parts from the center of the column in the bottom story na punta. So kagaina sa top man ta, so moto nakuha nato ang axial forces nga Q, R, S, ug T. So karon na napud mo adto na pud ta sa bottom part nga story. We have made the expression for the axial forces in terms of VQ. In the similar way, we can make expression for VN, VO, and VP in terms of VM. So, mao ni gihapon kay same distance naman pod sila. So, mao ra gihapon ang ilahang value kagaina sa Q, R, S, ug T, which is ang VN is 0.5 in terms of VM. Then VO is equals to 0.25 in terms of VM gihapon. Then VP is equal to 1.25 in terms of VM. So now, let us take as the moment about M. So kagaina, same processor gihapon gayna sa atong gibuhat sa moment Q. Nakakuha gihapon ta og 18 times VP plus 10 VO minus 4 VN minus 46 times 7 minus 23 times 2 is equals to 0. So ang katong gihapong VP, VO ug VN alisdan lang gihapon to siya og mga value nga nakuha kagaina nga same ra gihapon sa VR, VS ug VT, which is 0.5, 0.25 and 1.25. Then naka-come up og answer nga VM is equals to 368 over 23 is equals to 16 kilonewton. So same sa gibuhat nato kagaina sa R, S, o T, same processor gyapon nato ang pagbuhat sa pagkuha sa VN, VO, o VP, which is ang VN is 0.5. I-times mo siya sa 16, which is katong 16, inakuha nato siya sa VM. Yan, nakakame up kag 8 kilonewton same sa VO, 0.25 times 16 is equal to 4 kilonewton. Then VP is 1.25 times 16 is equal to 20 kilonewton. And that we have calculated the axial forces just above the center of the columns below the center. So mao ni ato mga value nga nakakuha para diriya sa atong axial forces nga sa bottom area, which is ang M, N, O, and P. Now, using the axial forces, we can find the shear forces in the beams. First, let us find the shear force in the member IG, which is diri. Now, to get the shear forces in the beams, we need to do the summation of forces vertical in each member. So first, we need to get the vertical force in member IG, which is summation of forces vertical is equals to 0, negative 5 plus V is equals to 0. So mukamat kag answer nga V is equals to 5 kilonewton. And sa member GK, which is negative 5 plus V minus 2.5 is equals to 0. So we get V is equals to 7.5 kilonewton. At the same process siya sa bawat member, KL, HG, GF, and EF. So, ang atong answer sa KL is 6.25 kilonewton. And then sa atong EF is 11 kilonewton. Ang atin sa FG is 16.5 kilonewton. And then sa GH is 13.75 kilonewton. And now, we are going to find the moments in the columns will be acting clockwise direction. In a member, the movements will be same at both of the ends. For example, let us take the member IE, which is diri nga part, kaya nga to mag-moment naman ta diri so ang ilahatan ng direction is pa clockwise. And now, let us use the shear force and find the moment in the beams. To find the moment, we will going to use the formula W L over 2 para pangitao nato ang moments in the beam. Using the formula WL over 2, we can get the moment in beams, which is the MIG is equals to MGI is to get 5 times 4 over 2 is we will come up the answer of 10 kilonewton meter. Same area lang, same kuan sila, same ragyapon sila moment kay ang I of G maura man ang ilahang distance which is 4, and then ang ilahang force is ang 5 and then over 2 which is 10 kilonewton per meter. And same sa MGK, which is 7.5 times 6 over 2, we will get the answer of 22.5 kilonewton meter. And then MKL equal MLK is equals to 6.25 times 8 over 2. So mukhang aptag answer nga 25 kilonewton meter. And then ang MEF same ra gyapon sila og kuan sa MEF gyapon kay parihara gyapon ang ilahang long distance and ang value, which is 11 times 4 over 2 is equals to 22 kilonewton per meter. And then sa MGF is 16.5 times 6 over 2 is equals to 49.5 kilonewton meter. And last is the MGH is 13.75 times 8 over 2, which is 53 kilonewton meter. Now, in the joint I, if the moment is 10, the moment MIF also should be 10. So for MEI also should be 10. In the similar way, we can find the value of MLF. To get the value of moment IE is ang atong nakuha kagaina nga sa moment member IG kagaina ang nakuha nato is 10 kilonewton per meter. Same ra siya sa moment nga makuha nato sa member I ug E, which is 10. Then same diri pod sa member LH, ang ato nakuha kagainang nga moment is 25. And then sa MGF is i-add ra nimo 22.5 plus 10, which is 32.5 kilonewton meter. And sa MGK is 22.5 plus 25, mao ng 47.5 kilonewton meter. And then sa MEA is 22 minus 10, 12 kilonewton meter. And then sa MFB is 22 plus 49.5 minus 32.5, which is 39 kilonewton meter. And then sa MGC is 55 plus 49.5 minus 47.5, which is 57 kilonewton meter. And last is the MHD is 55 minus 25 is 30 kilonewton meter. In this frame, we have calculated all the movements. We have calculated the shear forces in the beams. And now, let us find the shear forces in the columns. First, let us find the shear force in the member IE. For that, we have to add these two movements. 10 plus 10 divided by the length, value 5 is equals to 4. We have calculated all the shear forces. Now, we are going to find the actual forces in the beams. For that, we have to use the shear forces in the columns. Since these 2 points, loads are acting towards the right side, the actual force in the beams will be compressive. And now, let us take the joint I. In their joint, let us apply the rule summation of forces horizontal is equals to 0. So to get the forces in beams, we need to apply the rule of sigma h is equals to 0. So here is the sigma h is equals to 0, 42 minus 13 minus h is equals to 0. So ang h nato is 29 kilonewton. O sa diripod nga member, which is sigma h is equals to 0, 42 minus 13 minus h is equals to 0, makakuan gyapon taog 29 kilonewton. Ang diripod nga area is sigma h is equals to 0 is negative 10 minus h is equals to 0, so we get the 10 kilonewton. And also here is sigma h is equals to 0, which is 10 minus 15 plus h is equals to 0, so atong h is 5 kilonewton. Problem number 2, using cantilever method or single bay at 2-story frame. Analyze the frame using cantilever method. The columns are assumed to have equal cross-sectional areas. Assumption. The points of contraflexure or points of inflection of the moment diagram in both the vertical and horizontal members are located at the midpoint of the each member. The actual stresses in the columns are proportional to their distances from the centroid axis of the frame. So let us name the center of the columns in both of the stories. In this frame, we have only one beam, so the center of the gravity lies in the center. To find the center, we have to divide 5 by 2. When we do that, we will get 2.5. So our x bar is 2.5 meters. So i-divide lang ni nato siya og 5 to get the x bar is equals to 5 over 2. Our x bar is 2.5 meters. So diri ang ato ang center. Did you get it? So sa gibuhat po nato kagaina, i-divide gihapon nato atong frames by 2, which is the top and the bottom. First, unahon nato ang top. So we need to get the moment of G diri as. So 5 times VH minus 20 times 2, kay 2 man to ang atong center diri as. So naa siya tag 2 meters o 2 meters is equals to 0. VH is equals to 40 over 5. So ang atong final nga answer sa VH is 8 kilonewton. So 8 kilonewton atong H. 8 kilonewton. Then ang ato pong VG kay same area raman pod sila, same length ra pod ang ilang kuan, ang ato gihapong G is 8 kilonewton. And then to get the moment of I, 5 times VG minus 20 times 6 minus 10 times 2 equals to 0. VG is 140 over 5. And then ang atong final answer is 28 kilonewton. Yeah, dude. Ang atong I kay same ato ang VG is 140 divide 5. So ang final answer niya is 28 kilonewton. 28 kilonewton. Same ra gihapon sila kay ang sa VI pod is 28 kilonewton pod kay same area raman pod ang ilahang gikuanan og ang same length ra gihapon ilang kuanan. So atong VG is VG is 28 kilonewton, tapos ang atong I is 28 kilonewton. So we have calculated the actual forces in the columns. Using the actual forces, we can find the shear force in the beams. First, let us find the shear force in the beams EF. So summation of forces vertical is equals to 0. Ang atua is negative 8 plus V is equals to 0. So atong V is 8 kilonewton. So ang atong shear is 8 kilonewton. Sa member EF ni siya, EF, and then sa member let us find also the shear force in the member CD. So summation of forces V is equals to 0. 8 minus 28 plus V is equals to 0. Our atong share is 28 kilonewton. So ano siya ang atong actual forces, which is yan ang atong. Now, using these two shear forces, we can find the movements. For MEF and MFE is 8 times 5 over 2. So, we got 20 kilonewton meters. So, ang ato ang movements is 20 kilo, ang atong sa MEF o MFE is same ra sila. So, mao na atong nakuha nga 20 kilonewton meter. Same sa MCD o sa MDC, 20 times 5 over 2 nga distance, we got 50 kilonewton meter. The movements in the beams will be acting in the clockwise direction. Now, for moment EC is equals to MC, same ragyapon sila kung ang imuhang moment diya is 20. So, ang moment po nimo sa CE is 20 pod, og sa FD, og sa DF is 20 lang, 20 gihapon. And now, let us take the column CA. The MCE is equals to MEC is 50 minus 20, so we got the CE and MEC is 30. So, same ragyapon po siya sa MDB o MBD, 50 minus 20, so we got 30 gihapon. Thirty. Diri is 20. In this analysis, we have calculated all the movements. We have calculated the shear forces in the beams. Now, let us find the shear forces in the columns. Let us find the shear force in the column EC. We have to add these two movements. 20 plus 20 over 4 is equals to 10. So we need to add the movement which is 20 plus 20 over 4 is equals to 10. Same process sa gihapon ang pagkuha. We have calculated the shear forces in columns and beams. We have already calculated the actual forces in the columns. Now let us find the actual forces in the beams. For that, we have to use the shear forces in the columns. The actual forces in the beams will be summation H is equals to 0, 20 minus 10 minus H is equals to 0, then H is equals to 10 kilonewton. Let's go.
That ends your topic?
Thank you and God bless.